So here is another question. It is given that an electric dipole with a dipole moment of 4 into 10 to the power minus 9 coulomb meter is aligned at 30 degree with the direction of a uniform electric field of magnitude 5 into 10 to the power 4 Newton per coulomb. Calculate the magnitude of torque acting on the dipole. So here it is given that we have a dipole with a dipole moment of magnitude 4 into 10 to the power minus 9 coulomb meter. Okay, this is the dipole, but this dipole is aligned at an angle of 30 degree in the direction of a uniform electric field of magnitude 5 into 10 to the power 4 Newton per coulomb. We have to determine the magnitude of torque acting on the dipole. Now we know torque acting on a dipole placed in a magnetic field is given by dipole moment magnitude, electric field intensity magnitude, and sine of which the angle makes the dipole axis makes with the electric field. So here theta is equal to 30 degree, E is 5 into 10 to the power 4 Newton per coulomb, and dipole moment is already given. So simply we have to put the values 4 into 10 to the power minus 9 into E, which is equal to 5 into 10 to the power 4, and sine 30 degree by 2. So this will be equal to sine 31 by 2 and 5 20 by 2 10 to the minus, it will be 10 to the power minus 4, 10 to the power minus 4 Newton meter. Okay, so this is the torque acting on the electric dipole. So here this formula is very important. Okay, so this is it. So here is another question on electric dipole. So it is given that a molecule of a certain substance has a permanent electric dipole moment equal to 10 to the power minus 29 coulomb meter. A mole of this substance is polarized. Polarized means it is oriented, it is aligned in a particular direction with respect to the electric field, in a certain direction at low temperature by applying a strong electrostatic field of magnitude 10 to the power 6 volt per meter. The direction of the field is suddenly changed by an angle of 60 degree. Estimate the heat released by the substance in aligning its dipoles along the new direction of the field. Okay, so the situation is that we have electric field in a particular direction. Okay, and we are considering a particular molecule in which the dipole, let me use a different ink. Okay, the dipole is aligned in a particular direction, any angle it makes with the electric field. Okay, it is aligned in that direction with respect to the electric field. Okay, for one molecule we are talking about, one molecule, single molecule of the substance. Now it is given that the electric field, the direction of the electric field is suddenly changed by an angle of 60 degree. Okay, the direction of the electric field is suddenly changed by an angle of 60 degree. It means the dipole will also get rotated, as the direction of the electrostatic field changes. Whatever angle it makes, this is the angle of rotation of the electric field. This is the angle of the dipole which it makes with the electric field, theta d, theta e. So it means to rotate the dipole, some amount of work has to be done on the dipole. We know the formula: work done in rotating a dipole through an angle theta, that is given by what? The formula is P E into 1 minus cos theta r, the angle of rotation. The theta r is the angle of rotation. So here P is the dipole moment, which is equal to Q into 2A. E is the electric field, theta r is the angle of rotation. In this case, as the electric field rotates through an angle of 60 degrees, so the dipole will also get rotated by an angle of 60 degrees. Dipole moment is already given in the question. For a single molecule, the dipole moment is 10 to the power minus 29 coulomb meter. The electric field is given by 10 to the power 6 volt per meter. So theta r is already here. So for one single molecule, the work done is equal to 10 to the power minus 29 into 10 to the power 6 into 1 minus cos 60 degree. That is equal to, the value is equal to, it is coming, yes, 10 to the power minus 23, and this is 1 minus 1 by 2, so 0.5 into 10 to the power minus 23, this much joules for one molecule. Here it has been asked to find the work done or the heat released for 1 mole of that. So 1 mole, the value of mole we know, 6.023 into 10 to the power 23 units. So simply we'll multiply it. This is for one molecule and this is for this much molecules. So simply we'll multiply. We'll consider only this 6, rounding it off, the 6 part, 6 into 0.5. So 10 to the power 23 plus 20, 10 to the power minus 23, that will get neutralized, will get cancelled. So we'll be left with the work done for rotating 1 mole of the molecules, that is equal to 3 joules. Okay, when we multiply the 0.5 for one molecule multiplied with 1 mole, 6 into 10 to the power 23, this will get cancelled. 6 into 0.5 is 3 joules. So this is the work done in rotating 1 mole of molecule of the given substance. This will be the amount of heat energy which will be released because of the work done in rotating the molecules. Okay.